This is a model of an old-fashioned steam engine. The design was perfected about 200 years ago. Many people think this is what a steam engine should look like and act like. Needless to say, modern steam engines are almost entirely different, although they do have cylinders and pistons. There's a cylinder in here, there's a piston in here. This is a flywheel. And what we have here is defined as an overhung crank. In other words, there's a little knob sticks out there, and the big end of the connecting rod has a big end and it has a little end. The little end is where the wrist pin is in a normal car engine. So this is an overhung crank which is set up on an eccentric. So as this goes back and forth, it turns the main shaft, which turns the flywheel. The connecting rod here comes to the little end, and this is called, there's a sliding doohickey thing here which slides in a groove so it goes straight back and forth, which is technically called the crosshead. Then you have another piston rod, which is not the connecting rod because it doesn't wobble back and forth. It just goes straight back and forth, which is this little rod here. And it goes straight back and forth, keeps this all lined up straight because the piston, unlike a car engine which has a trunk piston, and the wrist pin is way up in the piston, and it goes back and forth like this. Here the piston is very, very thin, and it goes straight back and forth, and it's held in place because it's on the end of this rod, and actually the piston itself does not touch the cylinder walls. Only the rings touch the cylinder walls. So that's how this works. Then over here we have an eccentric with a bearing, and this is the valve actuating mechanism, and as you can see, this goes back and forth because it's on an eccentric. So we have a pin here, we have a rod here, there is a little sliding piece of metal in here. The chamber here is called the steam chest. Steam pressure is on the outside. The little doohickey thing goes back and forth. It exposes some little slots milled into the side of the cylinder, and it lets the steam in. When the piston is at one end, it lets the steam in. The piston goes all the way back, has a power stroke. Then the other one goes this way, pushes the exhaust out. The exhaust goes out through the same passages, and the exhaust comes out somewhere in here. What is interesting about this is, you may not notice, but the crank pin, the two crank pins are at a 90-degree angle. This one here, for example, is horizontal. This one here is completely vertical. By having these pins at 90 degrees, you're assured of two things. One is this engine will never be in balance, which is why they always run at less than 1,000 RPM, because they're impossible to balance. Secondly, the pistons are never at top dead center or bottom dead center. One of them is always right in the middle of a stroke, and so it will start from a dead stop. It'll start with good torque, and that's all you need to know. It's a very, very attractive engine in that it doesn't need a clutch, it doesn't need a gearbox, All it needs is a valve that turns the steam on and off, and I'll show you how the Stanley engine, which is exactly like this but larger. And this is exactly like the old steam locomotives worked. Many of the early steam engines, donkey engines, the steam shovels that made the Panama Canal in the early 1900s had three things like this, called donkey engines, in them, which ran different parts of the boom and the buckets and the steam shovel thing, and was enormously effective. Very inefficient in the sense that you never were able to cut off the steam partway in the stroke to allow it to expand down. It always had full pressure and thus full torque. And this is a little toy, does a nice job of showing all the important parts. The overhung crank, the pin out here, the eccentric that drives the valve is here in the steam chest. Steam comes in here, goes into the steam chest, steam gets distributed into the cylinder, the top of this, each side of the end of the cylinder. It's called double acting. All of your car engines and all modern people have single acting engines. This is double acting. And by being double acting, you have the fewest number of parts to make something that will start from a dead stop. And if you put a Stephenson reversing link in this, you can run it frontwards and backwards. No gearbox, no clutch, no nothing. All it takes is a valve. A lot of work was gotten out of engines like this.